So here we have 2 kg ice. So take 2 kg of ice cubes in the beaker. Ice cube, if they did not give the temperature, then it is 0 degrees Celsius. 2 kg of ice cubes. Now we are adding boiling water. Boiling water to that. How many kilograms of water? mkg of boiling water. Boiling water is at 100 degrees Celsius. So we are adding enough water to just melt the ice. mkg of boiling water we are adding. Immediately the 2 kg of ice melts and the final temperature is 0 degree. 0 degree water, yes. At the end, we have 2 kg plus mkg of water at 0 degrees Celsius. Are you able to follow, ma'am?
Yeah.
We have taken 2 kg of ice at 0.
Ma'am, what's the formula? Is it still C delta T?
Hello. Mama. சொல்லுங்க, குயிக்கா சொல்லுங்க, நோ ப்ராப்ளம். ம் 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 Okay. Offline is going good. I've observed. Pakarnan. Okay. Bye. Sure. I want to hear. Yes. Okay, ma'am. Bye. Okay, so we have taken 2 kg of ice and we are adding mkg of boiling water. Finally, we have 2 plus mkg of water at 0 degrees Celsius. Are you able to follow, Vishwa, the question?
Yeah, ma'am.
They have given specific heat capacity of water is.
Ma'am, what's the formula? Is it still MC delta T?
MC delta T if there is a heating or cooling. If it is phase change, ml. So Q is equal to MC delta T for like no phase change. If there is phase change, latent heat is equal to Q by M, or I can say Q is equal to ml. As simple as that. Only two formula. So when the ice cube, 2 kg ice cube, so let us look at how they have given. They have given the specific heat capacity for joules per gram. So better convert it into grams. So given mass of ice is 2 kg, which is 2000 grams. Let m grams of boiling water be added. Assuming that, look at the presentation. These are all small nuances that you should. Assuming that there is no loss of heat energy given by the boiling water is equal to heat energy required for the ice to melt. So heat energy lost by boiling water is the heat energy gained by the ice cube. So this is according to conservation of energy. So What is heat energy lost? This is the heat energy lost by boiling water. Heat energy gained by the ice cube is this one. Do you agree, Vishwa? This
Yeah,
is
but
for
I don't know.
100-degree water. 100-degree water is cooling. There is no phase change. But the ice cube is melting. There is a phase change. Do you follow, Ma?
Yeah, kind
Vishwa, you are not unable to follow?
of. Kind of, I'm not really understand.
Maybe we should do the simpler question first.
Yeah, ma'am. Can we do the first few questions again?
Okay, I will share the link also to you, recording. Look at this question. So, what is the heat energy required to melt 5 kg of ice? This is only phase changes involved, melting from solid to liquid. So, they've given specific latent heat of ice is 336 joules per gram. So if they give it in kg, you can preserve it in kg. If they give it in gram, convert it into gram. So
Yeah,
mass.
ma'am, I understood this, ma'am.
Okay, so
I
this you
understood
understood.
this.
Okay.
This was a simple question.
Yeah, look at this question. Temperature of 300 gram of water. So you have taken 300 gram of water, which is 40 degrees Celsius. Now some ice cubes are added, and now the final temperature is 0 degrees Celsius. So they added m grams of ice cube. Now that ice cubes got melted, and the water is also 0 degrees Celsius. So two things are happening. One is 300 gram of water is getting cooled, and number two, this is one. Number two, the ice is getting melted. Are you able to follow?
Kind of, yeah.
So two things are happening because we are adding two substances together, mixing two substances together. So step one, 300 gram of water cools from 40 degree to 0 degrees Celsius. This is step one. So for this, we will use Q is equal to MC delta T formula. Number two, the added ice cube melts, and it is from 0 degrees Celsius. It is remaining in 0 degrees Celsius. Only thing is from solid to liquid it became. So for this purpose, we have to use Q is equal to L into M dash, because we have taken M dash grams of ice. Is that okay?
Yeah, ma'am.
So look at this. Heat lost by water is MC delta T. 300 grams. Specific heat capacity of water is 4.2 per gram. Delta T is 40 minus 0, which is 40. So this many joules is lost by the 40 degrees Celsius water. Now, M dash gram of ice is added to the mixture. So what is the heat gained by it? Since it is phase change, we have to use this formula, M dash into 336. So assuming, you can say principle of calorimetry.
Yeah, ma'am, I understood this, ma'am.
You understood? Principle of method
Yeah,
of
ma'am.
mixture, principle of calorimetry. You can write. Same way here we are extending it. 100 degrees Celsius is becoming 0 degrees Celsius. M gram of ice from 0 degrees Celsius to 0 degrees Celsius, it is getting converted. The phase change is happening here.
Ma'am, can you scroll down a little bit?
Yes.
Yeah.
So write like this, assuming no heat energy is lost, heat energy given by the boiling water equal to heat energy required for ice to melt. Or you can use principle of calorimetry, principle of mixtures, anything. So MC delta T is equal to M into L.
ml.
Hmm.
Yeah.
So what is heat energy lost by the boiling water? MC delta T is equal to M into L. They gave 2 kg of ice cube. So you can find how much boiling water is present initially, or how much water we are adding, how much boiling
Yeah,
water.
ma'am. Yeah.
Are you getting 1.56 kg? Ma'am? No confusion. Very
Yeah.
simple. 4 marker. All these are 4 markers. I want you to be very confident and comfortable.
Today,
Hmm.
you got numericals and biology.
Really?
But they were like,
What is that? Energy required,
no, like,
energy chain.
in a nuclear tile or something,
Hmm.
all the components,
Hmm.
one component weighs this much,
Hmm.
and in theory, that component is equal to another component.
Hmm.
So, what is the third? How much is the third component? Like
Easy
that.
one.
Yeah.
Ma'am, they started stoichiometry in chemistry.
See, they will complete soon. That's why we need more time.
Ma'am,
Stoichiometry
but
we can do for 3 weeks.
ma'am, but stoichiometry is so easy.
They may do only the empirical formula question. Okay, ma'am.
Ma'am, they're doing mole concept, whatever that is.
Okay, ma'am. Heat energy is supplied at a constant rate to 400 grams of ice at 0 degrees Celsius. Ice is converted into water at 0 degrees Celsius in 5 minutes. Okay, so you have taken a beaker full of water, 400 gram of ice. Oh, okay. 400 gram of ice at 0 degrees Celsius. Ice can be -3, -4 also. So watch out what is the temperature given. So this is the ice cubes. Now you are heating it with, constantly you are heating it. And ice got converted to water in 5 minutes. So time is 5 minutes, or 5 into 60 seconds. How much time will it need to raise the same water from 0 degree to 100 degrees Celsius? Okay, so it took 5 minutes to melt. So heat energy required to melt 400 gram of ice at 0 degrees Celsius is M into L. We know it is 400 grams of ice. L is given as 336 joules per gram. So this much heat energy is needed. And the heat is supplied in 5 minutes. They have kept it in minutes only. They did not convert it into seconds. No problem. So 134400 joules, they are constantly heating, constant rate. So 5 minutes, that means each minute this much energy is supplied to the ice cubes.
Now, where is taken 1, 3, 5, 6,
1, 3.
1, 3, 4, 4.
That is M into L.
Oh, yeah.
So this much energy is spent by the Bunsen burner in 5 minutes.
Yeah.
Now, how much more time we should keep it on so that it will reach 100 degrees Celsius? So heat energy to raise the temperature from 0 to 100 is MC delta T. So here we have phase change. So we use that formula. Here we only heat up. Heating. So we have to use MC delta T. So same energy is used to raise, same rate we should find out. So if you want to raise 400 grams of water to 100 degrees Celsius, you need this much temperature. What is the time required? So time required is equal to Q by 26880. You agree?
Yeah.
Vishwa?
Yeah, ma'am.
168,000 divided by 26880.
Yeah, ma'am. I understood this.
So if you see,
Now, how much? What's the first class?
in T minutes, we need that much, like got it as 6 minutes, 6.25 minutes. Why don't we convert it into seconds? Will that be better? So we have 300 seconds. So 134400 divided by 300. Is it divisible by 3 table? 4 threes are 12. Again, 4 threes are 12. 448 joules per second. 4 threes are 12. 4 threes are 12. So 448 joules per second is the heat energy supplied by the Bunsen burner. So here we can calculate time using same. So heat energy required is 16800, which is 448 joules per second into time. So time is equal to 16800 divided by 448. Go ahead, solve it. 224 times 84 times 112 times 42,000. 56 times 21000. 1000 by 56. This is divisible by 4 table, which is 14. Numerator is divisible by 4 table, which is 5 fours are 220. 2 fours are 8. 5 fours are 20, like this. Again, divide by 2 table. 2625. 2625 by 7. Go ahead, divide it. 3 sevens are 21. 7 sevens are 49. 5 sevens are 35. So time is 375 seconds. Or you can write 360 seconds plus 15 seconds. 6 minutes and 15 seconds. If you are comfortable with seconds, you can keep it like this.
From the lesson board,
They finally converted it into minutes.
we have to convert.
I think they have given like this, right? Either or. That means they will agree. 6.25 minute or 6 minutes 15 seconds.
No, we can't write 375.
They may cut half mark.
Oh.
Don't give any scope. Are you okay with 7th question, Vishwa? Shall we move on to 8?
Yeah, ma'am.
Calculate the power of an electric heater.
Ma'am,
Power energy, power is coming here. Yes, ma'am.
can I just calculate the whole thing into seconds, or is that bad?
Yeah. Second also is fine. Minute is also fine. Oh, you mean to say you want to leave it as 375 seconds?
Yeah, ma'am.
That's what she's also saying. But I think it's a good idea to convert it.
Ma'am, but there is no half mark system.
It's a good idea to convert it. It's 4 marker. 3 or 4 marker.
Okay.
To calculate the power of an electric heater required to melt 1 kg of ice at 0 degrees Celsius in 30 seconds if the efficiency of heater is 40%. So they're combining work power energy along with calorimetry. Hmm? So take specific latent heat of ice as 336 joules per gram. So mass is, they've given in grams, so you have to convert it into grams. They did not convert. Okay, let's see. They're converting latent heat to (336 into 10 power 3 joules per kilogram. 336.
Now we can just convert kg into the ice into grams.
Yes, ma'am. You want to do that way?
Yeah.
They've given in grams, so we'll convert it in grams. So mass of the ice is 1000 grams. And the ice is at 0 degrees Celsius. Time is 30 seconds. So what is the heat energy required to melt it? M into L. M is 1000. L is 336. So this is 336,000.
Ma'am, what's PT?
They are saying efficiency, work output or power output. Okay, output by input is efficiency, right?
Yeah, ma'am.
Into 100 is efficiency. So it is 40% only. So 40
Ma'am, what is P? What is T, ma'am?
power. When we study electricity lesson, we will be better with this. Again, we will study electrical energy.
Okay.
So the output is the electrical output. Only 40% of the input.
Ma'am, input
Electrical energy is electrical input energy. What is the power of the electric heater? You have to design an electric heater which satisfies your condition. Electrical input energy is equal to only 40% is getting converted. Electrical output energy is 40% of input energy. 40% of P into T. Did you study this formula, ma? P into T? Efficiency.
no.
Output by efficiency. I square RT. Q is equal to I square RT RPT. This you will study in electrical lesson. Q is equal to VIT. Okay, so we are taking this energy, electrical energy. 40% of that energy is converted. So 40% of electrical energy is equal to 336,000 joules.
Yeah. Ma'am,
Correct.
so input energy
40%
is
of
that.
power. Time is given as that. What is it? Yeah, input
Ma'am, so
energy.
input energy is 33600.
Output energy is this much.
Is that much?
Uh,
Oh, yeah.
Input
sorry,
energy
sorry.
should be
Yeah, I mean,
only 40% of input energy is
yeah.
converted to
Why
output
not we
energy.
just substitute in the above reaction?
Here,
Sorry, in the above equation. Yeah.
this one.
Yeah.
We are calculating that only. Output energy is 40% of PT. Forty percent of input energy.
Yeah.
If you want, you can write like this. Electrical 40% of electrical input energy is output energy. And that output energy is 336000. So 40% of input energy is 336000.
Ma'am, have you read this here? Or wait, not.
Okay, okay. You want to substitute there. We don't know output energy. Output energy we know.
Yeah, and percent efficiency also we know. Yeah.
Into time. You missed the T. Time is 30 seconds. Is equal to 336000. So cancel the 0.
Now, why do we
That is another
40% of power. Oh.
40% of this is the electrical energy formula, ma. You will study in that electrical energy lesson.
So we can't substitute the
Input, this is the input energy.
Yeah.
40% of input energy. P into T is the input energy.
So wait, so what are these colors?
You did not use the time.
Where do I keep the
Energy is C into T.
time?
Input energy is C into T.
Oh.
So if you want, we can revisit this again after electricity lesson. So P equal to 336000 divided by 4 into 3. Go ahead, cancel 112,000. Can cancel 4. 2 times 4, 8 times 4, 28,000 watts. Power is 28,000 watts or 28 kilowatt. Efficiency of heater is 40% only. So 40% of the energy supplied by the heater is used in melting the ice. So 40%. See, they have given nice wordings. If P watt is the power of the heater, energy supplied by the heater in T seconds is PT joules. Efficiency is 40% only. So 40% of PT is 336000. Are you able to follow?
Yeah.
Vishwa, is that okay? We have similar questions in end of the lesson. Vishwa, you okay to move on to the next?
Somewhat, yeah, ma'am. Sure.
Okay, if you want, you can mark it to be redone.
Ma'am, how many examples are there?
There is every question paper has a one question. I think I don't have the latest questions in this PDF. 1 kilogram of ice at minus 10 degrees Celsius. Okay, so it should become 0 degrees Celsius ice, and only then it should melt until the whole of it vaporizes. How much heat is required?
How does it go?
They are taking 1 kilogram of ice cube and it is frozen. So 10 degree minus 10 degrees Celsius. 1 kg of ice. Everywhere it is given as kg, so we can keep it in kg itself. So number 1, ice heats up from minus 10 degrees Celsius to 0 degrees Celsius.
How does it vaporize?
Number 2, ice melts. Ice at 0 degree melts to water at 0 degrees Celsius. For the first one, what is the formula?
MC delta.
MC delta T. For this, what is the formula?
ML.
For the third one, now the water at 0 degrees Celsius heats up from 0 degree to 100 degrees Celsius.
Ma'am, you know what our teacher
Mm.
said?
Mm.
Our teacher said that if we draw it like a diagram
Mm.
like this,
Mm.
it runs into water like that.
Mm.
And if we write in this, over here, this,
Mm. Mm.
if we write like that,
Mm.
we don't need to write the given. Sorry, we don't need to write any statements. Apparently.
Okay, there is one more teacher told that Boyle book gave like a table, and the board loves that answer. I'll show you the Boyle book also. So fourth question is, what is it? So water at 100, only for calorimetry, 100 degrees Celsius vaporizes. So again, we have to use M into L. 4-step question.
Now, 3 steps only, right? Oh, it vaporizes.
Mm. So for first one, use Q1 is MC delta T. So use the correct C. So specific heat capacity of ice is you have to take for the first step.
Yeah.
And that you calculated. Heat energy for the first step. Heat energy for the second one is M into L. Now third step, heat energy to
Ma'am,
raise the water. Yes, ma'am.
Isn't the vaporization, vaporization meaning conversion from liquid to gas or from,
Yes, yes.
so ma'am, won't it, oh, you're first calculating for water.
Mm. So specific latent heat of steam is 2268 into 10 power 3. So fourth step, we have to use the proper values. They've given so many values. So if by silly mistake, if you take the wrong value, gone case. M into L of steam. So total energy is Q1 plus Q2 plus Q3 plus Q4. So you need this much kilojoule of energy. You can start with your circles worksheet
Ma'am, which one is?
right next to fan. That is true. You are putting it off. You are putting it off the. Oh. Vishwa, are you okay with that?
Yeah, ma'am.
They've given one note also. In this case,
Fine.
they're asking what is the total heat energy needed to convert from ice cube to vapor. In this case, on the temperature time graph, the time in 4 steps will be proportional to the amount of heat energy taken in these steps. It will be in the ratio 21. Less time is taken for melting. If x seconds is taken for melting, for raising from minus 10 to 0, 16 times the time is taken for melting, 20 times the same time is taken for heating, and 108 times is taken for vaporization. Okay, now let's look at the 10th question. Yes.
latent heat for converting ice to water is 336 into 10 to the power of 6.
Shall we move on to the next one, ma'am? A cube of ice, 1 cube of ice of mass 30 grams at 0 degrees Celsius is added into 200 gram of water. (200 gram of water when the whole of the ice cube has melted. Okay, at 30 degrees Celsius. Now, calculate the final temperature of the water when the whole of the ice cube has melted. So, what will be the final temperature? Final temperature will be less than 30 degrees Celsius and more than 0 degrees Celsius. Do you agree? Final temperature T is more than T1, less than T2. Vishwa, do you agree?
Yes, ma'am.
Let the final temperature be T degrees Celsius. Heat energy taken by the ice to melt, so is Q1 equal to M into L. So 30 gram into, they've not given in joules, they've given in calorie per gram. 2400 calories. How was your test today? Do you have the question paper? Your school keeps it. Heat energy taken by the melted ice to raise the temperature from 0 to T degrees Celsius is the same. So MC delta T. This is for Nandini. So this mass is different because it is 200 gram and specific heat capacity of water is 1 calorie per gram. Delta T is 30 minus T. 30 minus T. So equate it. 200 times 30 minus T is equal to 2400. So transpose 200 to the other side. 30 minus T equal to 2400 by 200. (30 minus T equal to 12. Transpose T to the other side. 30 minus 12 equal to T, or T equal to 18 degrees Celsius. They completed area related to circle first and then they are starting circles. They are coming reverse order. Are you okay with this, ma'am? How come they are getting? Oh. Is it the same question that I'm checking? Heat energy taken by the melted ice to raise it to the temperature from 0 degree to 3 degrees Celsius. Okay, ma, I think I have to look at that question once again. I will do tomorrow morning. And 10th one. You can continue with maths, ma. Redo this question. Yeah. Vishwa and Nandini, you can go to maths. 10th question. 10th question is pending. I'm not getting the right answer. Okay. Keep 10th question pending.